basis of differentiation, and why we are doing this video is to help our students understanding the concept of physics. So we are going to be looking into basis of differentiation, integration, vectors, and solid angles. So I also believe it will help us in our mathematical understandings of some particular things we need to keep in mind when we face some questions for basic level on differential calculus. Now, about differentiation, what we call differentiation is actually from the word or the categories of what we relate as functions. Now, in mathematics, let me just try and keep it as simple as I can, which is my hobby. We talk about functions. Now, when we say functions in mathematics, we are totally talking about relations between variables. So next time you hear the word functions, just think about relation between variables. And if you are new to the word variables, we're talking about alphabet, which can be any of the alphabet. Here I just chose what x and y. So whenever you are doing relation between different variables, you are talking about functions. We can take a very simple examples. As you can see, you can say y is equals to x plus 2. This is a particular function which contains two variables x and y. In this case, if we substitute the value for x, we are going to get value for y. Now we can also have another expression in polynomial form like y equals to, let's say, x cubed plus 2x squared plus 5x plus 6. Now the same thing happens to this because we have two different variables. As you can see, when you put the value for x, you are going to have value for y. So in this type of expressions, this type of variables, you can say this equation, you call them expressions, which is very, very important. In this type of expression, we have different variables. As you can see, we have x variables and y variables. So we classify these variables into different categories. Now, the first categories I can quickly talk about is what we call the free variables. Now, free variables. In your some of the mathematical textbook, it is called independent variables. It's just an introduction here. Independent. So independent variable. Now, let us carefully analyze y equals to x plus 2. Now, in this case, if you watch very well, you can see that x here is a free variable because you can substitute any value of x. For example, let's say x is 1. 1 plus 2 is going to give me 3. I can say x is 2. 2 plus 2 is going to give me 4. So in this case, we say x is an example of what? Of an independent variable. Whereas the second type of variable, which is just a direct opposite of that, is the y here. Because y depends on x, and we call that a dependent variable. So these are the two classification of variables you have, which actually bring about the expression in mathematics we call function. So generally, the function relationship we use in mathematics to express y and x is now giving us what you see everywhere you go. Y is equals to f of x. So this is the expression that we use mathematically to express functions. So you can as well define functions as any expression that relates a dependent variable with an independent variable. So this is the mathematical expression we use to write y as a function of x, and we call it y equals to f of x. Now, having said that, we can quickly also introduce ourselves to types of functions, because we also need that to understand the concept of a basis of differentiation. There are different types of functions. As I've said, we write functions as y is equals to f of x. So if we consider this, generally I told you I'm doing this because of physics, which is also going to help us in mathematics. In physics, we classify functions into four. They are what we call the algebraic function. We have what we call another function we call trigonometric, or let me just short, trig functions. Another type of function which is important is what we call the logarithmic function. Logarithmic function. And the last type of function, which is very important in physics, is what we call the exponential exponential functions. So these are type of functions that we use in physics to express what? Different variables. Now, what do we call algebra function? These are functions that are expressed in terms of what? Polynomial form. That is the one in which, like the examples I've given here, we have y equals to x plus 2, or you can say the case in which the constant, here as you can see, the constant value, the values here, the powers are constant. They are not having any coefficient. Such can be an algebra function. It can be in any form. It's not necessary. It can be linear. It can be quadratic. It can also be in form of, for example, somebody writes y is a function of root x plus 6. It's an algebraic function because the variables which is the cause is what is constant, and the powers of variables are constant. So any forms of algebra functions that looks in this format are called algebraic form of function. Now the second type I have listed here, trig function or trigonometric functions. They are the one that deals with the 6 basic trigonometric values, like your cos, tan, tangent, cosec, tan. We are going to discuss extensively as we further on the differentiation basics. Now the logarithmic functions are the one that deals with log. For example, we say when we have log of a number, let's say log of a number, let's say log of 10, is always to the base of a particular number. So we are going to talk about how to differentiate log form of a function, and as well talking about exponential function. Those are the one in which you have them that is being raised to the power of what? A particular variable. So all these are going to be discussed extensively, and the methodologies that we use to differentiate each and every one of them will later be discussed in the other sections. Now, having said this, algebraic, trig, logarithmic, and exponential functions are the 4 basic type of functions we use in physics, and we are going to be talking about each and every one of them, how to differentiate each of them. So you need to be careful that also you can have a situation where you have a mixed function. I think that one is also very important, a mixed function. Now, in the case of mixed function, what we do is combination of 2 or more type of functions coming together, and you are going to what? You are going to differentiate. Yeah, you can also have that also in physics and mathematics. We are also going to look into that type of thing. For example, somebody can give you a function of y is equals to, let's say, 3x squared cos 2x. You can see there are 2 different type of functions here. I have an algebraic function, I have a trigonometric function. So all these are going to be discussed extensively as we further on the basis of differentiation going forward. Now the next thing I need to talk about now is to explain the word differentiation and how do we come about it. Now in mathematics and physics, it is very, very important to understand that the concept of differentiation simply means, let me just put a subtopic so us to understand what we call introduction to intro to differentiation. Now, as we've already studied that the function in mathematics is written as y is equals to f of x. Now, if we have a function that is written as y equals to f of x, the small change or elemental change in the variables, I told you variables are alphabet, is what we call differentiation. For example, what am I trying to say? For example, if we have a simple function, let's take this linear function of y is equals to x plus 2. Now, if there is an elemental change in y, we call it the y, and it's written as y plus the y. Now, if there is an elemental change in x, we write x as x plus the x. Then you have what? Plus 2. Now, the change in respect to y, that is elemental change with y, to that of x, is what we call differentiation. So students need to keep it in mind that an elemental is a very, very small change in a particular set of variable with respect to, that is the change in a dependent variable with respect to the change in an independent variable is called differential change, and that is what we call the y dx. And sometimes you see it as y prime, please. Sometimes it is also called derivative. I hope students are following all this. because a small change in the value can be written sometimes as y prime, it can be written as the y dx, it can be written as derivative of what? Derivative of what? Y. And it can also be written as y is equals to f prime of x. So anyhow you see this, what we are just trying to say is that a change in particular value, I told you about dependent and independent. Now, change in what? The one that is a dependent variable with respect to a change in independent variable is what we categorize as differentiation. So to understand this carefully and better, we can quickly analyze some example on how a differential change can be solved using the first principle, and how we come about that in mathematics and physics. Now, looking at that, you can quickly let us take our simple examples before we go to the other part of the video. Now, let us quickly do that by moving this a little bit up and looking at some other things which I think is also important. Now, let's take some examples. Now, we can take a simple example of a very simple one first. We can consider y is equals to 5x plus 3, which is a very, very simple example for us. Now, the examiner says find the y dx. Now, which is the same thing as y prime, or y equals to what? F prime of x. Now, in this case, the change in y is written as y plus dy. Should I write theta y or dy? I still the same thing. Is equals to the change in x is changing from 5, you have a open bracket, x plus dx. Then here you have plus 3. I hope students are following. Then if you expand the right hand side, you're going to have y plus dy is equals to 5 times x are 5x plus 5 times dx are 5dx plus 3. I hope students are getting this. Now, initially, what was y? Y was equals to what? 5 plus 3. So, y is equals to 5x plus 3 can be cancelled out. So, what you have now is the y. I said y is equals to 5x plus 3. So, y here is equals to 5x plus 3 can easily be cancelled out. So, when we cancel that out, we have change in y equals to 5. I'm using change in y here. Maybe it's better for me to use change in x, which is also the same thing as dx. You have 5 dx. So the y prime or the y ds is now change in y divided by change in x, which we call y prime or the y ds, is now equals to 5, which is the question answer. So this is the basis of what introduction to calculus, or what you call differentiation rather. You can always look for an elemental change on one side, relate it with the other side in the function, cancel the initial function out of the equation, then you have the answer to your y prime or the derivative of y, or if you like, you call it the y dx. So now that you've understood this is the basis of first principle. There are other ways you can also do that. We have formulas. I have some of my old videos online. You can also scroll down. You see about the one in which I give you f of x formula for the y dx. F prime of x equals to, you have f of x minus f of x plus h over h as limit of h tends to 0. That is another way, but I believe this is kind of very simple for us to do whenever you want to use first principle. Yes, it's also possible for quadratic form. Maybe we should take one more to understand the concept very well. Okay, fine. So let's draw a line in between this and quickly analyze another one. Now we have another one. We can take another example to understand the concept very clearly, in case we have a algebraic form. Now if we take another example, we have another example. Okay, we have if y is equals to 4x squared plus 3x plus 7. The question is we should find the y ds. So now, doing this, my dear student, we use the same principle we have just learned now and substitute the elemental change. So elemental change in y is y plus dy. I hope students are following. Elemental change in x is 4 open bracket x plus dx whole square plus 3 open bracket x plus dx. Then you have a plus 7. Now if you expand this, I hope students can expand very easily. You can expand a plus b all square. So this should give us 4 times, that is 4x squared, I just want to cut it short, I don't have time, plus 4x dx squared. I hope you understand this. Expand this first to understand my expansion. If you expand this one, you're going to get x squared plus 2x dx squared plus, you should know all these things from basics classes. So if you use 4 to remove the bracket, you have 4x squared plus 4x dx squared plus 8x dx. Then you have a plus 3x, this is 3x, very correct, plus 3 dx. You have a plus 7. So I hope students understand this. The next thing now from here is to cut the initial value. Y is equals to 4x squared plus 3x plus 7. So now another thing I want you guys to understand in when you are expanding squares is that we said the x is an elemental change, that is a small change. So because the x is an elemental change, the x squared will be very, very small and it can be neglected. So we say it is negligible. So in this case also, we cancel this value of the x squared. So what we have here, my dear students, is the y is equals to, I hope you are following, this is 8, we have 8x dx. Then we have plus 3 dx. Now, if you watch the here, it's very simple to make that sort of formula. But for understanding's sake, you can factorize and say the x is outside. You have 8x plus 3. I hope students understand this simple analysis. So the y dx from here will be equals to 8x plus 3. So these are the basis of your first principle, which you can keep in mind. And these are the way we solve this in physics. And the application is very, very important for you to always keep in mind. Then that is just for that. Then now we are going to talk about, like I said, we are going to consider each of these type of functions and talk about how to differentiate each of them. So for this slide, I will only discuss on algebra function. Then I'll continue with trigonometric function in the next slide, and as well as a logarithmic function and exponential function. Now, let us start with the topic of algebra function and how to differentiate. Now, to do that very quickly, we can say, so now we have a algebraic function, and how to differentiate. Now, to differentiate algebraic function, now that we have studied the basis of differentiation, we need to understand that differentiation of algebraic function has some what we call the direct differentiation formula. Direct differentiation formula. Now, using the direct differentiation formula, we use it directly to get answers to algebraic function. What are the direct the differentiation formula? The first one is if we have if y is equals to x to the power of n, then the y dx, these are elementary differentiation, remember, is the same thing as nx raised to power n minus 1. That is the first one, which is very important. The second one you can also keep in mind is if y is equals to 1 over x. This is also important for direct answers. The y dx, you can use the same formula. The power will come to the back, then you subtract 1 from the power. So in this case, 1 raised to 1 over x in mathematics is x raised to power minus 1. And if you do that, you are going to have negative 1 over x squared. So you can always keep it in mind when you have 1 by x, you substitute directly. The third one is if y is equals to root of x. This is the same thing as x raised to power half. Following the same law, you have the y dx is equals to 1 over 2 root x. So all these are direct formulas we use for algebraic function. And the last one I should talk about is if y is equals to a constant. I hope students know what I mean by constant. Those one without variable. The y dx is always going to give you 0. Now, going quickly to what we discussed not quite long, we can quickly analyze some of these things and look at them and see that these formulas is very, very important solving questions directly. The questions we have before was that the first one was y is equals to 5x plus 5. So if we look at this, from the knowledge of this, we can say the y dx will now be equals to, we deal with the power. The power here is 1. 1 times 5 are 5. So you have 5 x 1 minus 1 is 0. Anything to the power of 0 is 1. So 5 times 1 is 5. This is 5. This is a constant. It's always going to give you 0 from here. So the answer to this is directly 0. Now we can consider another one very quickly and look at the second example we have done there. And we have y is equals to 4x squared plus 3x plus 7. So looking for y prime, which is the same thing as the y dx, remember 2 4s are 8, 8x raised to power 1 plus 1 times 3 is 3, 1 minus 1 is 0, that's 3, and this is a constant which will go. So to avoid errors and other things and to make our works fast, it is always advisable to go with direct formulas of differentiation when you are dealing with algebra function. So students can keep that in mind. You can have other questions that are directly related. For example, maybe we should do one or two more. Y equals to x to the power of 5 plus 7 over x. Then we have plus 3. We can also do this directly. The y dx or y prime can be equals to, remember, 5, and this is x to the power of 4 because 5 minus 1s are 4, plus, remember, 7 over x is the same thing as negative 7 over x squared, because here, remember, 1 by x is minus 1 over x squared, and when you differentiate the constant is with 0. So you can remodel this and have 5x to the power of 4 plus times minus and minus 7 by x squared. So guys, we can just stop this here. Next slide, we are going to look into how to differentiate logarithmic function and some other type of functions, exponential functions, as well as what the other type of function which are called the mixed function. So guys, see you soon. You have a wonderful time. Bye for now.